So in this shaft chapter, let us take one numerical from our latest winter 2019 exam. The statement of the problem is in front of you. A lathe receives power from an overhung shaft situated exactly above the lathe pulley by means of belt drive. A pulley weighs 400 Newton of diameter, 270 mm is fixed on the shaft. The center to center distance between two shaft supporting bearing is 900 mm. Pulley is mounted 300 mm from left bearing. The maximum power required by the machine is 500 kN at 200 rpm. The belt tension ratio is 2.5. Determine the diameter of the shaft. Allowable shear stress for shaft material is 40 Newton per mm square. So this is winter 2019 exam problem. Now here, what is the given thing? So if you just see all the details, there is one pulley. You can see the pulley in the figure. There is a simply supported pulley which is mounted on a shaft having bearing to bearing distance of 900 mm. The distance from pulley to the left bearing is 300 mm. So you can see A and B as a bearing and C as a pulley in the figure. The pulley is having 270 mm diameter. Now look at the data given. The power is 5 kilonewton. So 5 kilowatt. So 5 kilowatt means 5 into 10 power of 3 watts. The speed of 200 rpm is given. Then the weight of the pulley is given as 400 newtons. Diameter of the pulley is 270 mm. It is a pulley, that means it has belt. One is T1 as a tight side, T2 as a loose or slack side. So the ratio between the pulley tensions T1 by T2 is given as 2.5. So that means T1 equal to 2.5 times T2. The shear stress, permissible shear stress is 40 Newton per mm square. So this is the given thing. Now here, what we want to find is the diameter of the shaft. As here, the power is driven by the pulley. So power means torque. That torque will create torsional shear stress, as well as the weight and belt tensions may create bending. So this is the combined problem of bending as well as torsional stresses on the shaft. So let us one by one try to get the torque transmitted and moment so that you can find the diameter by using our equation. So as you can look at the right side here, power means 2 pi nt by 60. So power is 5 into 10 power of 3. So 2 pi 200 rpm multiplied by torque T divided by 60. So power torque comes out 238.732 Newton meter. It comes in Newton meter because watt is Newton meter per second. Watt is nothing but joules per second, so it is Newton meter. So now torque is 238.732 into 10 power of 3 Newton mm. So this torque creates a torsional shear stress inside the shaft. Okay, now let us go further. Next thing that we want is the moment which is going to create a bending stress in the shaft. For that, we need to know the bending moment. So let us go further. Now here, as we are interested in forces on the pulley which creates a bending. So for that, weight of the pulley is known, but T1 and T2 is directly not given. So for that, look at that T1 by T2 equal to 2.5. So T1 equal to 2.5 times T2. We know that the torque T is nothing but T1 minus T2 into R. Put the value of torque, already we got in the last step, 238.732 into 10 power of 3. T1 in terms of T2, that is 2.5 into T2 minus T2, and the diameter of the pulley is known. So radius is 270 divided by 2. So from this, T2 comes out 1178.92 newtons. You can put that T2 in T1 equation so that we can get T1 is 2947.31 newton. So now these are the two tensions of the belt, which is again in a downward direction. So total weight of that particular point where the pulley is mounted is total weight equal to weight of the pulley plus T1 plus T2. So 400 plus 1178.92 plus 2947.31. So total weight comes out 4526.23 newtons. So this much amount of weight is directly on that particular point. Now here, this particular weight is going to create moment, and that we want to find out. So this is very simple case of our simply supported beam. Now here, by simple way we can see here. So this is the simply supported beam. So these are the two bearing positions, and here at a distance of 300 there is a weight Wt. So Wt is the weight which comes here. So this is now because of this, it creates a bending moment. So bending moment will be like this. So bending moment diagram will be like this. So this is the bending moment diagram. Now because of this that we want to find out, there is a bending of this particular beam. So that we want to find. Okay. So let us go further, try to get the equations. So we want reactions here. Now for the reaction, so why it is necessary to have reaction? Because we want to find the reactions at RA and RB so that we can find the bending moment at the weight position. Again, you can see here. So here, this is our reactions. So there is a RA reaction here, and there is a RB reaction here, because these are the two bearings, and at the bearing there is a reaction. So we need to find this reaction because of the weight Wt. Because of the weight Wt, we are interested to find this. So how we can find this? So it is very clear. So if you take total vertical forces, then RA and RB are the vertical upward forces, which is equal to weight 4526.23. This is one relationship. Now there are two unknowns, so we can simply go for a moment about A. So now we can see here there is a clockwise moment which we consider as a negative. So Wt multiplied by 300 is the one moment. There is an anti-clockwise moment Rb multiplied by 100. If you take the moment about this A, so if you just take the moment here, then there is a moment about this Ra. So this is the point A. So if you take the moment here, now this is the moment about WT, which comes out WT into 300. So if you take moment about here, so it is exactly opposite to this. So it comes out RB equal to 900. So from this we can get the value of RB. RB comes out 1508.744 newtons. So if you put that RB in our first equation, if you put this RB here in the first equation, then obviously if you take this RB here, then RA plus RB equal to 4526 will get RA. Okay. So by this way, we can find the reaction at RA and RB. Now, if you take all the moments, moment at A will be 0 because it is a support. Moment at C, moment at C means moment exactly at weight point. So find moment at here, that moment is nothing but RA multiplied by 300 or RB multiplied by 600. So you can take any of any side. So RB multiplied by 600 we have taken. So it comes out 905.24 into 10 power of 3 Newton. So this is the maximum moment. This is the maximum moment. Generally, in our strength of material, we find this particular moment diagram like this. So this is the moment diagram. So here the moment is maximum, and this is the max. So that moment that we can find like this. So this is the bending moment diagram. So bending moment diagram already in our strength of material we have already find this. So this is the bending moment diagram. Here the maximum bending moment is here, which comes out RB. So you can put RB multiplied by this distance. So this distance is 600. So RB multiplied by 600 will be the moment from the right side, which is positive generally consider. So RB multiplied by 600 is the moment. So moment at B is also 0. So maximum moment which comes out is at the bottom of the load. So this completes our bending moment calculation. So bending moment calculation that we can find like this. So for any type of uh, shaft that may be, you can find the bending moment like this. Once we got the bending moment, now remaining thing is very simple because torque we know, M we know. We have equation. So that equation is very simple here. So tau max into pi by 16 d cube equal to under root m square plus t square. So this is the equation that we know. Here, the shear stress is given. If the direct stress is given, that means we have to consider that pi by 16 sigma uh, n d cube equal to m plus under root m square plus t square. That equation we have to consider. But here tau is given, tau max. Generally, it is subjected that the shafts are fail because of torsional twist. So maximum shear stress is the failure condition as per the our maximum shear stress theory. So here pi by 16 tau d cube equal to under root m square plus t square. So if you put all the values, m we know, torque that we know, here the shear stress given is 40. So if you put here together, then definitely you will get the diameter equal to 49.21. So 49.21 is the odd figure. We must round off to next integer. So d equal to 50 mm. So by this way we can find the diameter of shaft. This diameter of shaft, this equation or this particular problem is asked for almost 6 marks. So if you find diameter D equal to 50 mm, definitely you will get the full marks of 16. So this completes our one problem on shaft which is asked in 2019 exam.